Okay, so number 5 says, what changes should be made to the KVP and MAS in order to reduce patient dose while maintaining constant receptor exposure? This is the answer, but it goes from the PowerPoint that she went over, Charlene did. This example question, she said, an acceptable radiograph of the knee is produced using 10 MAS at 60 kVp. If the kVp is increased by 15% to 69 kVp, what MAS would be needed to maintain the exposure? For anything like this, especially if the kVp is increased by 15%, you have to cut the mass in half. And so if the mass was 10, then that's going to be 5. So in order to maintain the same exposure. So it's asking here too, what changes should be made to kVp and mass? Actually, I think I have to change this because mass should be kept in half, but then kVp is increased by 15%. So the amount of mass should be brought down to half in order to maintain a constant receptor exposure. And then I'm going to have to add kVp can be increased by 15%. Because those two kind of go hand in hand. So with this number 6, then it says an image of the lateral knee is taken at 68 kVp, 10 MAS, and is repeated. Whatever. The radiographer wants to decrease contrast but maintain the same receptor exposure. If the kVp is increased to 78 kVp, what should the new MAS be? So I kind of wrote it out here. So 68 was the first kVp. If we increase that by 15, so I multiplied that by 15% to see what the value is. Because essentially you would think that 68 and 78, that's like a 10% increase. But actually the calculation shows that 68 times 15% is 10. So it's going to increase about 10 kVp. Like exactly 10.2. And so 68 plus 10.2 can show that it equals 78, which is here the new kVp, so that makes sense. So that adds up. So then to go back to that kind of 15% rule, I just added that to show that's how I'm explaining it. So current MAS is 10. New MAS is 5. Half of that 10 is needed to maintain the same receptor exposure.